Hey guys, welcome to the Linux channel. So recently I have done a video episode on how I have set up my entire WAN emulator with Toffee Mocha inside a VM. So in case if you haven't watched that episode, you can watch the same. So here is the episode, so you can watch the same. And in this episode I'm going to discuss about how I have supported a new upcoming feature called jitter feature. So the idea about it is I need something which performs more like a frequency modulated signal, so that you diagnose a traffic pattern or the bandwidth delivery of these packets, so the test packets. You need something like a frequency modulated signal, so that you get a burst of packets for a set duration, and then followed by which it should reduce the frequency of the number of packets being sent, so that effectively it just drops down, the bandwidth drops down, and then again this burst starts. So I need a pattern like that. So I need something like a frequency modulated signal, so something like this. So if you Google, you can find the same. So you get the difference between an amplitude modulated signal versus a frequency modulated signal. So effectively what is happening is, if you do a sort of frequency modulation, it is going to have this sudden burst of traffic, and then followed by which it is again going to transmit the packets at a much slower rate. So what I have done is, I have done the setup this way. So you can go back and watch my previous episodes, so that you get that full idea about my whole entire setup. So with this, here is my pfSense router which is running, and here is my Toffee Mocha setup over here. So I have supported the new jitter feature. So till I don't release this new Toffee Mocha, you may not find this in the existing Toffee Mocha. So once it is released, you can start using the same. So I have these various settings. Jitter, you can enable and disable this delay, and then you can control the rate or the frequency with this jitter factor. So since it is not something like hertz or something, you can't do that way. So it has some kind of logical way that you set the jitter factor as more larger number, it is going to reduce this frequency, so that it will be more relaxed. And if you set the value as lesser towards the value, the least value you can set is 1. So if you set the value as 1, what happens is it is going to increase this frequency. So when you set the value as 1, you can't almost detect it anymore. It may be just few packets, it will be coming at a higher rate, and then followed by which it will suddenly drop the delivery of the bandwidth or the packet rate, and it is going to flip-flop between these two states. So and down you can see, you can set a minimum and a maximum value in the form of, you can set any scale in the form of microseconds or in the form of milliseconds, and then maximum range you can also set it is whether it is milliseconds or microseconds. So you can also do a sort of flip-flop. You can even set the minimum range in the form of milliseconds and maximum range in the form of microseconds. So technically it is not a bug. Effectively you are just setting two states instead of having something like a constant delay over the top. So you can see there, in the case of constant delay, it's just a specific constant delay throughout, spread across, whereas a jitter, it is like it is flip-flopping back and forth, so something like that. So once these kind of settings are done, so for example here is my port settings. So you can see here I have two ports configured as LAN and WAN ports. So as I said before, it doesn't matter which way you configure, because effectively this is just a WAN emulator. Unless until you do any asymmetric delays like upload and download delays, it doesn't matter much. So with that, the traffic is passing through this way. It is going to pass through Toffee Mocha and then through pfSense router, and effectively it is going to go to my host PC. And in case if I need internet, I can reach internet to my test PC via this way. Also I can even reach my host PC to the test PC in this way. So this is my test PC. So right now I am doing a file copy. I have done an SMB share. So it is my host PC. You can see here it is in the subnet 192.168.0.88, whereas this one, let me open a terminal. So if I do if config, it is in that subnet of 8.0 network. So it is 192.168.8.0 is the network. So the pfSense router is 8.1, and this is getting a DHCP IP from pfSense router through Toffee devices. So you can see here it is currently showing this file operations. I am copying this file. It's a large tarball. It's around 3.1 GB to my local PC. And you can see here this is the speed at which it is getting from there. So for demonstration purposes, I have increased the delay like as much as possible, like 10 milliseconds. So this way you can slow down and you can effectively see what is exactly is happening. Since it is entirely deployed in VMs, there is going to be some amount of performance overhead. So if I don't set it in the form of milliseconds, or else I don't enable any sort of delay, what is going to happen is it is going to still have some amount of bandwidth throttling, because it is effectively configured in the entire thing in a VM. So with that, you can go here, you can see the graph in the pfSense. I have remotely connected this pfSense through the Toffee Mocha, because it has a dedicated port which is a configuration or management port. So with this I can just reach directly to the external networks as well as this internal VM network. So it is connected to this PF router. So you can see here it is showing this pattern. It is suddenly flip-flopping between two states. Actually, you may notice, you may assume that it is going to this high bandwidth and then followed by which it is taking for a longer time, but it is not the case. Whenever it switches to the high bandwidth state, in that short duration it is completing all the transfer of packets, and then again it is going back to a lower bandwidth state, wherein which it is delivering packets at a lower rate. So this is the reason it gets this sort of spiky look. So this frequency, effectively what you can do is you can change over here. So currently it is in the jitter factor value is 20. I can set it somewhat like 10. So with that it will change, it will take some couple of minutes to update in the kernel, or else at the max around a minute. So once it is updated, this frequency between two states will change, and also you can control the jitter max and minimum milliseconds and microseconds delay. So this is effectively going to change your entire look of your graph. So you can see here it is going to change the way the graph is being plotted. So you can see here the frequency is more increased, so it is like it is going to flip-flop much sooner between these two states. So you can see here the frequency is almost changed, so it is flip-flopping much faster than before. So this way you can use the jitter factor, and if you remove the jitter altogether, currently there is no other delay which is set in this device, so which means it is going to transfer at the full speed. So let us just wait for again a couple of seconds. So with that, it is suddenly going to open up and it is going to blast the traffic at the full speed as much as possible. And as I said before, since it is VM, it is going to flip-flop here and there, because it will have some amount of overhead, unlike a real physical setup. So you can see here, once it is removed, it is completely at the full speed of as much as possible in this VM setup. So it is currently showing around 25 or else 1.7 Mbps, or the current bandwidth is around 25 Mbps, as you can see there. So with that, you can go back to this system. You can see here it suddenly opened up and it is finishing this file transfer much sooner. So hope you guys loved watching this video. So shortly I'm going to also publish a sort of test article, so that either of that you can refer. I'm going to take some of these screenshots and I'm going to publish over the same. So in case if you have any questions, you can discuss in discussion forum, or you can send an email or discuss in the YouTube comments. So thank you very much for watching this video, guys. Have a nice day. Bye bye.